Okay, for classwork video 110, I'm going to have you show all this work onto the handout provided and then write down the 5 words to show me that you listen. All right, trying to just tie this all together again from the equation to graphing to everything that you should know for math readiness. Get ready for math 1. First word is shark. Shark. All right, so again, be able to write this equation using that $3 per hour. That's going to be my rate of change, $3 for every hour, plus that 2. That's going to be my y-intercept, or when x is 0, how much I'm paying, the y-intercept. And then this is giving me the deposit. And then again, just know the parts of equations we're looking at here to get you ready for math 1. Slope intercept form, where this number is the rate of change number, how much it's changing each time. This number right here is the y-intercept, or where you're starting. For this problem right here, it's me giving you the y number and you trying to find really what x was at that point. So that's what this is. It's me giving you that this is 8 already, the total cost. So those parts that you got to know. But for this equation, 3h plus 2 equal 8. First thing, take away 2 both sides. That will give me 3h equals 6. And then right there, divide by 3. And that gives me, at that point, to get that $8, I had to be spending 2 hours out there. All right, know now how this relates. That equation really that we're looking at there is 3h plus that 2 equals some unknown cost. That's really my equation that we're using there. If I was using that in regular slope intercept form, that would be y equals 2, not 2, y equals 3x plus 2. If I was doing it just good old-fashioned generic equations. So know that those are the 2 equations that apply to this situation right here. $3 per hour plus that $2 deposit. I want you to, next word is log. Thanks for listening. Fill in your table. This is 0, 1, 2, the y-intercept, or that point, 3, 4, and 5. The y-intercept right there, I don't know, I do see it's 2, but I want you on this table to see that we have 2 hours given. So that's this number right here. I know that after 2 hours, the total cost was 8. So I know that part of the data table. I could get every other number in this data table by adding or subtracting by this y-intercept number, by this $3 per hour. I could take that 8 and keep adding threes to get every number in the other table, subtracting 3s going up the table to get those other numbers. 8 plus 3, 11, plus 3, 14, plus 3, 17 going up. 8 minus 3, 5, minus 3 gives me 2, that all-important y-intercept, that 2, the y-intercept number right there. Or, of course, I could use that equation if I wanted to. I could find any number in there, write this down for full credit, by plugging in 4 for h maybe, or for time, to figure out the c. That gives me, of course, 14 right there, that same number I'm looking at on my table. So know that you could use the equation instead of just that plus or minus 3 to get every number in the table. Next word is tree. Tree. All right, I want you to be able to graph this, knowing that this is like a regular equation where this is my y-axis, this is my x-axis, but of course we're using t and we're using C for cost for the y-axis here. All right, graphing this, I need you to know how to graph a normal equation. This is y equals 3x plus 2 technically, where you start at 2 on the y-axis. That's your y-intercept. That's when x is 0, what y is. And then, of course, all my other points, over 1, up 5, over 2, up 8. That's that point in the data table right there. Over 3, up 11. Over 4, up 14. Over 5, up 17. Draw a straight line through those. That line goes on forever. All right, next word is stick. Stick. Now all the high-tech stuff you need to know from this graph. That point, which is 0, 2, has lots of meaning. That means at 0 hours, maybe, the cost you already spent was $2. This graph shows that every time I go over 1 hour, my bank account is saying I'm adding an extra $3. $3 per every hour is being added to my bank account, plus that $2 already charged early. If I wanted to use and show that equation here, either y or the c, maybe plugging in that 2, here are the details. I got 3, which is really $3 for every hour. And I'm timesing that at that point for 2 hours, plus in that equation that $2 I'm already spending for my deposit. Is that going to equal that $8 in the table? It should. So watch this. These hours cancel. That gives me just $6 plus that $2. That should equal that $8. And again, that matches perfect, even with all the details, even with all the units, knowing that that rate of change number has special units, $3 per hour, $3 per hour, $3 per hour. All right, write all of this for full credit. Last word is rock. Rock. Good luck.